Okay, so in this video we're going to be looking at factorizing by completing a square. So by the end of this lesson, that's exactly what you'll be able to do. Factorize quadratic expressions by completing the square. And when we say completing the square, we mean a perfect square. So like maybe x plus 2 all squared. That's a perfect square, which expands to x squared plus 4x plus 4. So what it means is we're going to take parts of the expression and manipulate it in a way so that part of it now becomes a perfect square, and then we can factorize it back into that. So let's have a look at question A. Here we have x squared minus 18x plus 3. What I'm going to do is I'm going to take the first bit, x squared minus 18x, and then I'm going to halve the 18, ignoring the sign, the minus sign, whether it's plus or minus, just ignore it. I'm going to halve it and square it. Half of 18 is 9, and 9 squared is 81. So I'm going to add 81. But because I added 81, I'm going to minus 81 as if nothing ever happened. And then I'm going to write my plus 3. Okay, so if we have a look at this, it's like they cancel each other out. It's exactly the same question. But the reason why I'm doing this is because I want to create a perfect square, which is what I have done with this. This is now a perfect square, which is x minus 9 all squared. Okay, because half of 18, or half of minus 18 is minus 9. But what about this bit? Well, minus 81 plus 3 is minus 78. Can we factorize this? Well, yes, we can. It is a difference of two squares because of this minus sign right here. If that was a plus sign, we cannot factorize it because it's not a difference of two squares. So yes, we can. It now factorizes to, well, maybe I'll make these a bit bigger. X minus 9, x minus 9. Put my plus sign, put my minus sign, and square root 78. That's it. Alright, question B. I'm going to take my first two terms, x squared plus 10x. Then I'm going to halve my 10 and square it, which is 25. So I'm going to add 25 and minus 25 as if nothing had happened. And then I'll write my plus 37. Okay, there's my perfect square. I will factorize that to make it x plus 5 all squared, because half of positive 10 is positive 5. This bit here, minus 25 plus 37 is positive 12. Can we factorize this? No, we can't. Can't factorize because it's not a difference of two squares. That is not a minus sign. Not a difference of two squares. Okay, so we can't factorize that one. What about question C? We've got x squared plus 10x plus 7. So I'll take my first bit. I'll halve my 10 and square it, which is 25. But I still need to write my plus 7. That's my perfect square. X plus 5 squared. And this bit now becomes minus 18. Can we factorize this? Yes, we can. It is a difference of two squares because of that minus sign. So it will factorize to x plus 5, x plus 5, plus minus the square root of 18. Okay, so just remember, when we are factorizing a difference of two squares, we need to square root the first term. And when we square root that, it cancels out with the square, so I'm left with just x plus 5. That's why I write x plus 5 in both of these. And then we need to square root this. Okay, that's my final answer. Alright, pause the video, have a go with D and E. And when you're ready to check your answers, continue playing the video. Okay, so I'm going to take the first two terms, a squared plus 4a. Half of 4 is 2, 2 squared is 4, so plus 4 minus 4, minus 1. This bit here is a plus 2 squared. This bit here is minus 5. So yep, we can factorize this. It factorizes to a plus 2, put my plus sign, put my minus sign, square root of 5. Right, question E. X squared minus 8x, half of 8 is 4, 4 squared is 16, so plus 16 minus 16, plus 17. This bit is equal to x minus 4 squared. Okay, just remember minus 4 because half of minus 8 is minus 4. And this bit here is plus 1. So no, cannot factorize. Because it's not a difference of two squares, that is not a minus sign. Alright, pause the video, have a go with F and G. Last two. Okay, so I'm going to take the first two terms, b squared minus 7b. I'm going to halve that 7, which will be 7 on 2, and when I square that, I get 49 on 4. But I still need to write that minus 2. So this factorizes to b minus 7 on 2, all squared. And this is equal to minus 49 minus 8 minus 57 on 4. Okay, can we factorize this? Yes, we can. It is a difference of two squares. So let's bring out our brackets. B minus 7 on 2, B minus 7 on 2. Put my plus sign, put my minus sign. And the square root of 57 on 4. Now, if you want to simplify this even further, we can square root the 4 to make it equal to 2. So if you want, we can do it like this. B minus 7 plus root 57. And that bit is all over 2. And here we've got b minus 7 minus root 57. And this bit is over 2. Okay, so just remember, because the square root of 4 is 2, and then it'll have the same denominator as this one, so we can put minus 7 plus root 57 all over 2 as one fraction. Alright, and last one, we've got c squared plus 19c. When we halve 19, we get 19 on 2. So when we square 19 on 2, you get 361 on 4. Okay, so this is equal to c plus 19 on 2 squared, and this is equal to negative 381 on 4. So yes, we can factorize this. C plus 19 on 2, c plus 19 on 2, plus sine minus sine, square root of 381 on 4, 381 on 4. Now I don't think we can square root 381. That's right. So my final answer will be c plus 19 plus root 381, all of it, well, just that bit, over 2. And c plus 19 minus root 381, that bit, over 2. And that's it for this video.